Hello students, welcome back to my channel. So in this class we will discuss dipole moment. It is represented by mu r p and it is denoted by crossed arrow. This point towards more electronegative atom. This cross is nothing but a tail of this crossed arrow towards less electronegative atom. So here in this dipole moment concept mainly we will discuss the bond moment of the bond pair of electrons. Bond moment means the displacement of bond pair of electrons will be taken place from less electronegative atom to high electronegative atom. So whenever both atoms are having same electronegativity, bond moment does not take place. So whenever that electronegativity difference is more, that bond moment will be taken place. So in this process, we will get two charged species, means poles. Okay, two poles we will get. So two means a die. Okay, pole means is nothing but a charge. So it is a hypothetical process or hypothesis or a assumption. It is just assumption. So here due to the difference in the electronegativity, the displacement of bond moment of electrons will be taken place. So due to this, what will happen? The element which has more electronegativity will get partial negative charge, and the element which has less electronegativity will get partial positive charge. Okay, so here it will be possible whenever that atoms are having electronegativity difference. If electronegativity difference is zero, then bond moment of that bond pair of electrons does not occur. Okay, come to the main point, dipole moment. So that is mu is equal to q into d. Q into d. So what is the meaning of q? Q means charge of charge of pole. Charge of pole, it is either positive pole or a negative pole, is nothing but cation or anion. Next to d means internuclear distance. Internuclear distance or bond distance. Internuclear distance between two charged poles. Two charged poles. Two charged poles. Okay, so this is mu is equal to q into d. So what are the units of dipole moment? What are the units of dipole moment? That is a dBi. DBi is a dipole moment. So generally we take a capital D. So here capital D, that is 1D. 1 dBi is equal to 3.33564 into 10 power minus 30 coulomb meters. It is in SI units. SI units. Okay. Here the dBi in CGS unit is, that is 1 into 10 power minus 18 ESU centimeters. ESU means electrostatic unit. Electrostatic unit. This is a dipole moment. Okay, here moment of what is the dipole moment of electrons? So bond moment means the the displacement of the displacement of bond pair of electrons. Bond pair of electrons. Bond pair of electrons towards towards more electronegative atom. More electronegative atom is called bond moment. Is called bond moment. Bond moment. Okay, so here bond moment is represented by this crossed arrow. Okay, here this formula is for, it is for only diatomic molecule. It is for diatomic molecule. Diatomic molecule. It is for diatomic molecule. For polyatomic molecule means here if more than two bonded atoms, if more than two bonded atoms, okay, or if molecule contains two or more atoms, that is called a polyatomic molecule. So it is for only AB type molecules like this, okay, like a HOCl example. Only two atoms are there. Two atoms means diatomic molecule. If more than two atoms are present in the molecule, so we should use this formula. So that is a resultant dipole moment. Resultant dipole moment for polyatomic molecules. For polyatomic molecules. So for example, AB2, AB2, AB3, AB4, etc. So A is the central atom and B is the bonded atom. B is the bonded atom. For this type of molecules, how to determine the dipole moment? Okay, here this is A is the central atom. A is the central atom. It is bonded to two B atoms. Two B atoms. Okay, here between these two atoms with respect to central atom, here some angle is present. So this angle is making, that is a theta. So that is between two bonded atoms with respect to central atom. So here this red color, this is a crossed arrow, represents a bond movement of the bond pair of electrons. Okay, here this bond movement of electron pairs will be occurred from A to B, because here B atom has more electronegativity. If you consider B atom as more electronegativity compared to A atom, what will happen? The bond movement will be taken place from less electronegative atom to more electronegative atom. Okay, so that's why here B will get a partial negative charge, and A will get a partial positive charge. Okay, so to find out the dipole moment, that is net dipole moment, mu r is equal to under root mu1 square plus mu2 square plus 2 mu1 mu2 cos theta. This is the formula to determine the resultant dipole moment. So mu r means resultant dipole moment. Resultant dipole moment. Resultant dipole moment. Clear? So this formula is used to only for polyatomic molecules. Okay, here the dipole moment of the molecule mainly depends on the symmetrical molecules and asymmetrical molecules. So symmetrical means, here if a molecule contains same kind of bonded atoms without lone pairs, that is called a symmetrical molecule. Asymmetrical molecule means that molecule contains different types of bonded atoms. So if a molecule contains different bonded atoms, they are having different electronegativity, means difference in the bond moment, then dipole moment is not equal to 0. So that's why for symmetrical molecules dipole moment is 0. Dipole moment is 0 means bond moment will be cancelled. Okay, now we will see examples for both uh, types of molecules. Okay, first one is symmetrical molecules. Symmetrical molecules. Second one is asymmetrical molecules. Asymmetrical molecules. Symmetrical molecules and asymmetrical molecules. So symmetrical molecules, for this mu is equal to 0. Mu is equal to 0. Asymmetrical molecules, mu is not equal to 0. Mu is not equal to 0. Okay, now we will see some examples. For example, linear sp hybridization, beryllium fluoride is there, or beryllium chloride, whatever it is. So that is a, we can take, just where is the tester? Okay, here I will take two examples, beryllium chloride, and one more is carbon dioxide. One more is carbon dioxide, C double bond O, C double bond O. Okay, two are having same shape and same hybridization. Same hybridization. Okay, so here what is the bond moment? Tell me. So here the electronegativity of fluorine is 3. 3. Here also 3. The electronegativity of beryllium is 2. Okay, 2 or 1.5. 1.5 I think. Carbon is a 2.5, boron is 2, and beryllium is 1.5. Sorry, 1.5. Beryllium is 1.5. Okay, so now here which is having more electronegativity? Chlorine has more electronegativity. So here towards more electronegative atom, bond moment will be taken place. Bond moment will be taken place. So here bond moment takes place from beryllium to chlorine. Here also beryllium to chlorine. So here both chlorines are both chlorines are bonded to beryllium in linear position. So means bond moment will be cancelled each other. Cancelled each other. So here dipole moment is 0. So here also in carbon dioxide, oxygen electronegativity is 3.5, 3.5. Carbon is 2.5. Which is more? Oxygen has more electronegativity. So that's why bond moment moving toward moving towards oxygen. So here also, here left side and right side bond moment is equal. So that's why net dipole moment is 0. Okay, next to come to the asymmetrical molecules for the sp hybridization or linear structure. Okay, for example, if you take a like this beryllium, here one side I have taken fluorine, one side I have taken chlorine. Okay, here the electronegativity of fluorine is 3 and fluorine is 4 and beryllium is a 1.5. 1.5. So now tell me, compare to beryllium, both bonded atoms are having more electronegativity. Here bond moment towards fluorine, here bond moment towards chlorine. Okay, so here the bond moment is opposite side. So both are opposite inside. Okay, but here listen, the bond moment is not equal to 0. So not equal. Both are not equal. Here chlorine, here electronegativity is 3. Here fluorine is 4. Okay, means both are not having same electronegativity. Means bond moment also not equal. If bond moment is not equal, so then dipole moment is not equal to 0. Dipole moment is not equal to 0. Here bond moment of chlorine and fluorine are not same, are not same. So that's why dipole moment is not equal to 0. Next example, next one is for sp2 hybridization means without lone pairs, only bond pairs are there. So for example, boron trifluoride, boron trifluoride, boron trifluoride, boron trifluoride. Okay, here electronegativity of fluorine is 4, 4. Okay, boron is electronegativity is 2, 2. So now tell me bond moment, bond moment towards which element? Fluorine, because fluorine has more electronegativity. So like this. Here, is there any lone pair of electrons? No, all are bond pairs. And it is a trigonal planar. Trigonal planar. Okay, so without lone pairs, if molecule contains same kind of atoms, dipole moment is equal to 0. Dipole moment is equal to 0. Here, these are in here like this. So trigonal planar. In this, the moment of bond moment of this one will be cancelled by these two, and it will be cancelled by these two, it will be cancelled by this one, these two. Okay, so net dipole moment is equal to 0. Okay, like that, if you take SO3, sulfur trioxide, hybridization also sp2, and it is also having trigonal planar shape. Okay, like this, sulfur trioxide. Okay, here oxygen electronegativity is a 3.5. Okay, sulfur electronegativity is a 2.5, which is having more electronegativity. So oxygen, so bond moment towards oxygen. Here also same, these are in a trigonal planar. So that's why the bond moment of one oxygen is cancelled by remaining two oxygens, like this. For both, dipole moment is equal to 0. Okay, for same hybridization of molecules, but having different atoms, Now we will see. For example, here, like this. Here fluorine, here chlorine I have taken. Okay, here also same, like this only. Okay, here now tell me what is the electronegativity of this one. Fluorine is 4 and chlorine is a 3 and boron is a 2. So bond movement towards fluorine, here towards chlorine. Okay, so bond movement is taking place away of the boron. Okay, in opposite side. But here the bond moment of this fluorine is not equal to bond moment of chlorine. Okay, so bond moment of fluorine is not equal to bond moment of fluorine. So there is no equal amount of bond moment. So that's why net dipole moment is not equal to 0. Net dipole moment is not equal to 0. Understand? Okay, clear. Next, come to the sp3 hybridization. For example, CH4 is there, methane, CH4, methane, tetrahedral shape. Okay, here the bond electronegativity of hydrogen is 2.1, but electronegativity of carbon is 2.5. So bond moment towards more electronegative atom. Okay, means from hydrogen to carbon, like this. Clear? Okay, so the bond moment of this one will be 1. The bond moment of this one will be cancelled by remaining 3. Like this, the bond moment of each one will be cancelled by remaining 3 in the tetrahedral structure, which is having a same type of bonded atom. Okay, if a molecule contains same type of bonded atoms without lone pairs, the dipole moment is equal to 0. Okay, so like that, take NH4 plus also, NH4 plus. So in this NH4 plus, here nitrogen is a central atom. Here 4 hydrogens are there, 4 hydrogens. Here the total charge of ammonium is plus. Okay, here hydrogen 2.1, here nitrogen is a 3. Okay, so bond moment towards a nitrogen, clear? So here also dipole moment is equal to 0. Okay, next to same structure, same hybridization, but difference in the type of bonded atoms. For example, take here Cl, CHCl3, CHCl3 or CHCl3, sorry, CHCl3, and I am taking one more, another one, like this. Okay, here CH2 Cl2, CH2 Cl2. So here the electronegativity of chlorine is 3 and carbon is a 2.5 and hydrogen is a 2.1. Here also same, chlorine is 3, hydrogen is 2.1, carbon is a 2.5. So here bond moment towards chlorine and towards carbon from hydrogen. Okay, okay, here also same, from hydrogen to carbon, here from carbon to chlorine, like this. Okay, so bond moment of carbon to chlorine and carbon to hydrogens are not equal. So that's why dipole moment is not equal to 0. Dipole moment is not equal to 0. Okay, so this is the differences between dipole moment of symmetrical molecules and asymmetrical molecules. Okay, in next class some more examples we will see. Okay, here only we learned only sp hybridization. This is a sp hybridization, sp hybridization, and it is a sp2 hybridization, and it is a sp3 hybridization. Okay, in next class we will discuss the molecules which belong to sp3d, sp3d2, sp3d3, and some exceptions are there. Okay, next class maximum I will try to complete this topic. I hope you understood. Thank you.